Okay, so in this tutorial, what I plan to do is write a Nim program that calls out to a C library and uses the functionality in the C library to do something. There is a description of this process in the Nim Manual. They've got a whole foreign function interface instructions, but I thought it might be useful to go through a demo of how it works in practice because I found it a little difficult to apply the actual manual to really linking to a real program. So what we'll do is we'll take an example program, and this program is called zpipe. It's part of the Zlib library, which does compression, both GZ compression and deflate compression, which is used all the time on like web HTTP calls and things. So the zpipe program is very simple. It's an example program they include of how to use the Zlib library, and it takes standard input, compresses it with deflate, and then outputs it to standard output, or when called with the -d flag, it will decompress the input and set the standard out to the decompressed output. So we can get this example code from the Zlib website. I've just downloaded the latest copy of their code. So let's do that here. I've got here a folder and I've got my notes here. So let's initialize it with Git just to make it so I can have the steps of this process. And let's download the Zlib library. So I'll curl with output the file name as is and download this library for us. Now, we have the tar.gz there, so let's tar-xf zlib. So now we've got the zlib directory there. So what I'm going to do is copy out of zlib examples zpipe.c, and we'll just put it here for ourselves. So let's jump into zpipe and see what it is. So it's a very small C program. It shows how to use Zlib's inflate and deflate commands. They've got a couple of versions there, but it hasn't really changed in a long time. So they're including some sort of Zlib library as well as some standard library functions. And then you've got a few functions listed here. So you've got def for deflate, as in compress a file. Further down we have inf for inflate, to decompress a file. Then we've got a zerror function, which is just to handle outputting errors. And then further we have the main function, which is what's actually called when you run this program. So let's compile it. I'll run gcc zpipe.c and output to zpipe. And if you run this, you'll get an error immediately. So I'm running under Fedora 39, but this should apply to any platform you're compiling. And what it's complaining is that it can't find this deflate init underscore function to run. And the reason for this is that we need to link to the Zlib, the Zlib library. So we can add -l for link in GCC, and Z, which is the name of the library, and this should allow us to compile it. And now you can see it has allowed us to compile it, and we have here zpipe, the actual command that we created. So if we run zpipe with -h, it will tell us the usage, zpipe, optional -d to decompress, pipe in the source, pipe out the destination. Okay, so let's make a test data directory, and we'll do some testing of this zpipe command. So if we do, let's actually make some test data in that test data. So what we can do is dd infile equals /dev/urandom, and we'll say byte size equals 4. So we just want 4 bytes of data. Count equals 1, so 1 block of 4 bytes of data, and then outfile equals test data / 4b.raw. So this will just give us 4 bytes of random data. And if we now run xxd on that test data, we can see that we have our 4 little bytes of data here, 1 byte, 2 byte, 3 byte, 4 byte. And let's now compress that. So /zpipe. Now we want to pipe in test data 4b raw, and we'll pipe out test data 4b.deflate. So that's the deflated, as in compressed version. Now if we run xxd on the .deflate version, you can see that this is the file, and it's actually gotten bigger. It hasn't gotten smaller, but the reason for this is that it's such a small file and it's completely random data, so it's actually not going to get smaller. Particularly when you have random data, it's generally not going to be compressible, not with a sort of lossless compression format like this. But what we can do is we can actually copy in our zpipe.c file. So this is a text file, which is much more useful for compression. Let's put that in our test data directory. And we will run again zpipe, and we'll give it zpipe.c, and I'm going to make zpipe.deflate. And now, if we list out our test data directory, you can see that the zpipe was 6.2 kilobytes, but the deflated one is 1.9 kilobytes. So it actually did get significantly smaller by deflating it. So our zpipe is working. This is the C version of it. And now we should be able to implement this in Nim and go through the process of that. So we'll start that in the next part.